Hello and welcome to Blackwatch International. My name is Cerven, and in this training video we will be looking at the Mk6 mortar. The mortar is used as a close-range artillery weapon to assist the platoon. The Mk6 mortar fires an 82mm shell. It also has the ability to fire smoke and flare rounds. The mortar has an effective range of around 3 kilometers, which makes it ideal for a platoon-sized force. First up, we're going to go over the mortar assembly. The mortar consists of two parts, each in the form of a backpack. To assemble the mortar, you need to have one of the backpacks on the ground and one on your back. Now look at the one on the ground and use your scroll wheel to select Assemble Mk6 Mortar. You can now move it around via the ACE interaction, disassemble it via the scroll menu, or enter it like any stationary gun emplacement. Make sure it is placed on even ground before continuing. Operating a mortar requires teamwork and coordination. All members should understand their role and what is required to complete various tasks. The mortar team consists of 3 roles: commander, gunner, and assistant. The commander is responsible for selecting a position for the mortar, communicating with the supported group, and supervising the operation of the mortar. Mortar gunners are responsible for operating the mortar by applying the firing data onto the mortar as ordered, and firing as ordered. Assistant gunners are responsible for calculating the necessary firing data. Next, we'll cover the 4 calculations required to achieve a firing solution. These calculations are azimuth, also known as bearing to your target, your horizontal distance from the mortar to the target, the altitude distance between the mortar and the target, and finally, wind speed and wind direction. We will now go over how to acquire each value and then explain the calculations. The azimuth is the bearing to your target. This value can be acquired in 2 ways. You can either find the target using your gunner's optics if you have a line of sight to your target, or you'll need to use your map tools. To acquire the azimuth using the map tools, do the following. Open the map and use the ACE self-interaction menu to bring up the map tools. Place the center of the map tool circle exactly on your location on the map. You may need to change your texture size if the map tools are unclear. Locate your target on the map. Do this either by using a grid reference or a map marker, and then rotate the long end of the map tool to your target, holding Alt and dragging the long end to the target. Now the arrow points at a certain value. Use the numbers on the outer ring. Use the mortar's optics to rotate it to the correct azimuth. As you can see, the azimuth on the map tools uses only 2 digits, while the mortar optics uses 4 digits. Treat the last 2 digits of these 4 as first and second decimals compared to the map tool. The distance to your target, or the range, is the next value to acquire. You can do this by either using a rangefinder, such as the vector, or more likely, you'll have to acquire this value using map tools again. To do this, place the start of the map tool's ruler on your exact location on the map. The digits on the ruler represent hundreds of meters. Next, we'll calculate the altitude difference between the mortar and its target. To do this, you must estimate the difference by finding the altitude of the mortar position on the map, and then subtract it off the altitude of the target location, even if this will produce a negative number. Next is to calculate the wind, which is done by the assistant gunner by opening the Kestrel 4500 from the inventory. This can be done by pressing the Home key. If you have the micro dagger equipped, then press Shift Home to cycle between the Kestrel and micro dagger. To begin, we will need to find out what direction the wind is blowing, which can be done with Shift K. From here, you will open up the Kestrel 4500 and use the up or down arrows to find the headwind screen. Press the middle button to set the heading to target direction and follow the device instructions to make sure it is set. This will provide you with 2 separate readings. The first will be headwind speed for the target heading. If the value is negative, it is a tailwind. The second reading will be the wind speed and direction. You will then need to use the Kessler to find crosswind. Use the up or down arrows to change to the crosswind screen. As before, you will press the middle button to set the direction to the target. This will give you 2 separate readings. The first value will always be positive, and you will need to check the second value for wind direction. You can also use Shift K for a visual of which screen the wind is heading. With all these measurements acquired, we will calculate the firing solution. Open the range table using the ACE self-interaction menu that is provided to the mortar team assistant. The range table is required to use the aforementioned values to calculate the firing data. You require 3 values to put into the mortar: the azimuth, elevation, and charge. First, open the correct charge tab on the range table. Try and find the range to your target on this table. If you can't find it, try to find it on a different charge tab. If you have found the range on the table, you will know the charge your mortar will have to use to reach its target. The azimuth is a pretty static number and is only subject to adjustments for crosswind. Add or subtract the value that is stated in the crosswind column for your target's range once per meter per second of crosswind speed. You subtract when the crosswind direction is left to right and add when the crosswind is right to left relative to the mortar. The elevation is the most dynamic value. It represents the angle your mortar will fire at and will influence the precise distance the round reaches. First, find the elevation value corresponding to the target's range. The difference in altitude affects the elevation, and you will have to adapt the elevation to account for any differences larger than 100 meters. On the range table, it is shown how much your elevation value should be adjusted per 100 meters difference in elevation. Finally, the elevation must be adjusted for headwinds or tailwinds. Find the headwind or tailwind value for your target's range in the range table and add or subtract it once per meters per second of wind speed. Now that all of the values have been worked out, you can fire the mortar. First, the gunner will have to aim for the right azimuth. Next, apply the correct charge using the F key. And finally, enter the correct elevation marked by ELEV on the mortar sight. You raise or lower the elevation with the page up and page down buttons. When these values are put in correctly, you are clear to fire using the mouse button. It is important to remember that the mortar is designed to hit targets within a 100-meter range, so don't stress over getting direct impacts. It is important for team leaders to get feedback from the squads about the hits so adjustments can be made if needed. If the round is long, then increase elevation slightly, and if it is short, decrease. If the rounds are off by a lot, recalculate the crosswinds and check the right information was imputed. Thank you for watching this video. If this video was useful, be sure to give it a like. Subscribe for more Arma 3 content and check out our website for more information on Blackwatch International.